Welcome back. Today we are going to be talking about a new module which is on statistics. Okay, so the first thing we study when we talk about statistics is using a scatter plot. So let's say that we have this data. It shows the number of mammals on the International Union of Conservation of Nature's Red List. So these are the endangered species during the years 2004 and 2012. Okay, and so there were, if you can see, 352, 348, 349, 448, 448, 450, 447, and 446. Okay, so what we're going to do is just put this information, put this data, take it from a table, and just put it on this graph. All right. So we have 2004, and then 2006. Okay, this is 2004. This would be 2006. Let me just bold these. So it's a little easier to see. 2006 is going to be 348. So let's see, this is 350. So it's going to be about here. Okay. 2007 is going to be 349. So it's really about there. 2008 is 448. It's a really big jump. It's about 450 here. 2009 is about the same. 2010 is about the same, just a little bit higher. 2011, it looks pretty much the same here, and 2012 is 446, so it's a little bit under there. Okay, so here is the scatter plot of the data. It looks like it jumps from 350 to essentially 450 between the years of 2007 and 2008, right? So here's this big jump of about 100 species here. Otherwise, it just sort of stays around the same area between those 2 years. So this is how you can construct a scatter plot. Now, this is interesting in some ways. It's a really kind of a funny scatter plot because usually we see points all over the place, but these points appear to be in kind of like two horizontal lines, this one and then this one. So it really appeared to leap up between 2007 and 2008, but this is just to illustrate how to create a scatter plot. We're going to talk a lot about scatter plots and finding ways to describe the relationship other than just the data that's been collected and put into a table. So this is just another way to visualize what's happening with these endangered species, or the number of endangered species between these years. So notice that this scatter plot ends up having a, this is called a break right here. And it indicates that we're starting at the value of 300. So it indicates between the origin and the first dash here, you're going to have a different, you sort of leap up in your range right here, or your add-on number is a lot bigger between the origin and the first dash than it is between the first dash and the next dashes up here. So this is okay to do this, to start from 0 and go to 300 and then jump up 25 every time. What you cannot do is go from 0 to 300 and then jump up in different increments between 300 and the rest of the dashes. Once you've established the pattern of increasing by 25 every time, you can't establish a different pattern. You can't have like another break, for instance. Now this break, you can think of it as like sort of smushing the, imagine that was a straight line and you pushed it together and it ended up being like a coil, right? Like if you straighten out a coil, it would be a straight line. Well, this is the opposite. If you take a straight line and push it down together, it would end up being smushed up. That's what that break is. It means that there's a whole lot of, you're sort of zooming in on the space between 300 and 475 because most of our data is in that space. All right, so there's no need to put the data between 0 and 300 to have that represented in your graph if most of your data is zoomed in between 300 and 475, for instance. Okay, so when we create a scatter plot, what's going to end up happening is we're going to talk about the relationship between the two variables. So this is the variable of year versus number of species. So what we do in statistics in general is we find different ways of gathering data, organizing data, displaying data, and using data to interpret relationships between variables. So for us, that was just two variables, year and endangered species. But anytime you have a variable on your X and your Y, we're interested in knowing how strongly they're related to each other. And we call that relationship a correlation. So the relationship between the X and Y are called a correlation. Now, the measure of the strength of that relationship is how strongly the points are clustered around a line. We're going to mostly study linear relationships. So we're going to be interested in relationships that mostly cluster around a line. Now, with any sort of data collection, there's always an idea that, you know, it's not as precise as it would be if it was just like in theory, right? So anytime you collect data, there's going to be small adjustments to the instruments that you use to collect it. You know, the people that are used to collect it might create little errors in the data. So even if you had a perfect relationship between your two variables, it will hardly show up that the points are exactly along the same exact line, right? So what we say in statistics is that there are the relationship is trending. It's trending upward or downward. We say that it's clustering around a line. But in statistics, we're never going to see all the points that exactly collinear. It's just that there's a relationship between the points, that they look like there's a pattern here, okay? And that has everything to do with the idea that when we collect data, our instruments are never as exact as they would be just if we collected it in our mind. Like, you know, every hour the sun goes down a certain angle in the sky. But if you measured that angle, you know, there's problems with the way that our sight works, the problems with the way that the instrument would be if we read it, and so on. Okay, so the relationship between X and Y is called correlation. And we're going to measure it with a number called the correlation coefficient. And we always denote the correlation coefficient with the variable R. Okay, so if you have a scatter plot and the lines appear, the points in the scatter plot appear to be clustering downward, right? So it looks like it clusters around a line that is decreasing. We say that there's a strong negative correlation, and we say that the correlation coefficient is -1. Now, what I forgot to mention is that the correlation coefficient ranges between -1 and +1. Negative meaning that the relationship is trending downward. 1 meaning that it's like if you had an exact correlation of 1, it would mean that the relationship between X and Y are exactly related to each other. That one movement with X creates one movement with Y, for instance. So it's like the rise over 1 would be exact for X and Y. So the closer it is to -1, if it's already determined to be decreasing, the closer it is to -1, the more closely the points are clustered around this line, okay? If the points appear to be clustered around a line that's trending upward, all right, we say that the R value is very close to 1, meaning these points, if they were exactly along this line, these points, then they would be along a line that has a slope of 1. But since they're not exactly along that line, the relationship, the correlation coefficient is going to be read as something that's very close to 1. It may be like 0.8 or 0.9, but it's going to be close to 1. Okay. A weaker relationship, a weaker scatter plot looks like the points are not as clustered around the line, and it's going to have a correlation between 0 and -1. Okay, but it's not going to be as close to -1 as a stronger relationship. And what we're going to do in the later lessons is we're actually going to calculate this correlation coefficient and talk about it a lot more, so you're going to be more comfortable with this, the understanding of these problems. If you have a weak positive relationship, the points are not as clustered around the line, and they're going to be between 0 and 1, but they're not going to be as close to 1 as a stronger relationship. So you can see these points are a little bit further away from this trend line going upward. Okay. And if you have no correlation at all between your X and Y variables, like minutes of study versus correct answers, it's hard to imagine that these two things aren't related to each other, but let's just say maybe it's minutes of study for your Spanish test versus correct answers on your science test or something. If you have no correlation at all, it doesn't appear that there's any pattern with the points. So unlike the points that we saw in the previous relationship, these points tend to be clustered around a line. these points right here have no association. So we would say that there's no association and no correlation between these two variables. Okay. Now, if the points are clustered around a line, we would say that the association is linear, versus if the points appear to be clustered around a curve, we say that that's nonlinear. Okay, and so we're going to mostly be studying linear associations and not nonlinear ones, but there's absolutely plenty of relationships, especially in biology and chemistry, in the sciences, that are nonlinear relationships, nonlinear associations. Okay, and one more thing for this lesson today is that oftentimes we feel like if these points lie along the line, so notice that what this means is that, one thing I forgot to mention when we were back here, is that if it's a positive relationship, that as the x increases, the y also increases. And if it's a negative, as the x increases, the y decreases as variables. So we're going to get into word problems where this is going to make a little bit more sense, because we'll actually have things for our x and y. But here I have two variables that have nothing to do with each other. So the jars of jam, let me make this a little bigger, jars of jam sold in New York State versus the number of CDs sold in Florida. So as you might imagine, these two things have nothing to do with each other. But it does appear that if I plot them out as a scatter plot, as the number of jars of jams that were sold in New York State increase, the number of CDs sold in Florida also increase. So this is a situation where just because these variables have correlation, they appear to have a strong positive correlation. So it looks like their correlation coefficient is close to 1. It doesn't mean that one causes the other one. So this is a really important idea in statistics. Just because it appears that there's a relationship between them doesn't mean that because jars of jams were sold in New York State, this caused CDs to be sold in Florida. Okay, there might be another variable. So let's say that like there was a snow day like we just had, right? And the jars of jams sold in New York State were very low on that snow day versus, and they were also, the CDs sold in Florida were very low on that snow day as well. Well, as, you know, as we begin to get in weather where people are out and about and they're buying more stuff, it may be that New York also sees an increase in their sales of every item, and Florida also sees an increase of sales of their item. So maybe temperature has something to do with both of these variables, making it so that people are just buying more, you know, in general. But it doesn't mean that these two things relate to each other or one causes the other one. There might be a variable that doesn't exist that we're not seeing here. Okay, a good example of this is the example of as the number of ice cream cone sales increase, the number of deaths due to swimming also increases, right? Why would we think that those two things have anything to do with each other? One doesn't cause. Does ice cream sales cause swimming deaths? The answer is, you know, no. Just because as one goes up, the other one goes up, doesn't mean that one causes the other one. It may be, in this case, it's probably because ice cream sales goes up in the summertime, and people also swim in the summertime, right? So as the summer months approach, both ice cream sales and death by swimming increase at the same time, but it doesn't mean that one causes the other. So be very careful. It's very unusual to say that one would cause the other. In fact, it takes a very intricate studies to prove that one thing causes another thing. But we can say that as one increases, the other one increases, or as one thing increases, the other one decreases. All right? So a lot of talking in this lesson today, not a lot of writing, but that's sort of what statistics is like. There's a lot of analyzing of information. So make sure that you've taken some notes on the things that I've expressed verbally in the lesson. And that's the end of it for today.